talk about inverse functions. Anybody have any idea what inverse functions are? A function inverted, okay. You're just using the vocabulary words that are there and trying to figure it out. That's good. To find the inverse function, switch x and y and solve for y. Y is and solve for y in parentheses. Because you don't always have to do that. Okay? So to find the inverse function, we switch x and y. And if we're in a situation where we need to solve for y, we need to solve for y. Does that make sense? Well, it may not make sense yet because we haven't done it yet, right? But that's how we're going to do the lesson today to find inverse functions. Okay? So let's start off with an example. Are you okay with that? Y equals x plus 5. So how did we say we're going to find an inverse function? So I'm going to rewrite this function, except I'm going to rewrite it as x equals y plus 5. Does that make sense? I switched x and y. Is this a situation where we need to solve for y? Yes, it is. Okay? I want to get the equation of the inverse function. Okay? How do I go about solving for y? How do I get y by itself? Minus 5 from both sides. X minus 5 equals y. This really, really freaks people out sometimes. What's the difference between these two equations? Nothing. But some people really don't like the y to be on the right-hand side. This is my answer. That's the inverse function. My directions for you mostly today are going to be, don't make it harder than it is. Okay? Y equals 2x minus 4. How do we find an inverse function? Switch x and y. So x equals 2y minus 4. And solve for y, right? Okay, how do I solve for y? Add 4 to both sides. X plus 4 equals 2y. Divide everything by 2, right? Y equals what? 1/2 x plus 2. Is there another acceptable answer here? What about this one? Is that an acceptable answer? Yeah. This one makes more sense to us, especially if we're trying to graph it, knowing slope and intercept, things like that. But this is also a perfectly acceptable answer. It's just, what are we going to do with it after? Does that make sense? Any questions so far? What did I tell you I was going to have to tell you all day? Don't make it harder than it is, right? Y equals 3x squared minus 9. What do I do first? Switch x and y. And solve for y. How do I solve for y? Add 9 to both sides. X plus 9 equals 3y close. Not yet. What do I got to do before I can take a square root? Yeah, I got to get rid of the 3 first, right? I have to divide both sides by 3. So 1/3 x plus 3 equals y squared. And now we can square root, right? Square root, y equals. Who put the plus or minus in the problem? We did, so what else do we have to remember? Can I say that again? Because I just told you the answer. Who put the square root sign in the problem? We did, so what do we have to remember? The plus or minus. Okay, sorry about that. I was trying to trick you, and instead I tricked myself. 1/3 x plus 3. Yeah? And of course, yes, we can write it like this if you prefer to write it like that. Is there another way we could have written this answer as well? Could I have just written x plus 9 over 3? Yeah. Just like it was right here, right? I just went ahead and divided each term by 3. Especially since the 9 was divisible by 3, right? Okay. Any questions? Don't make it harder than it is, right? This seems really simple, doesn't it? For some of you, yes. So let me see if I can throw a wrench in things. Let me try to make it simpler. This is a -10. How do you find the inverse of a function? Switch the x and the y. If all I give you is a list of ordered pairs, how do you find the inverse of a function? So what should this be? 1, 2, 6, 3, -10, 4, -2, 6. You didn't think I could make it easier, could you? Or did you? But I did, kind of, right? Just a different sort of a problem, isn't it? What if I give you this? Let's do this. What is this? It's a parabola that I didn't graph very well. Just use your imagination, right? I want the inverse of this graph. How do you find the inverse of a function? Switch the x and y. What point is this? 0, 0. So what should it be now? 0, 0. What point is this? 1, 1. What should it be now? 1, 1. What point is this? 2, 4. What should it be now? 4, 2. What point is this? -1, 1. What should it be now? 1, -1. What point is this? -2, 4. What should it be now? 4, -2. Here's what I think is interesting about this right here. Okay? If I drew onto this graph the line y equals x, is that an important line on this graph? What if I folded this up right on the line? What would I see? Wouldn't it be right on top of each other now? Why is that true? This is the line y equals x. What did I just do with x and y? I switched them. I made them equal to each other, right? So would it make sense that it would reflect across the line y equals x? Yeah. Any questions about that? Any questions about inverse functions? So tell me, how do you find an inverse function? How many times do you think I'm going to ask you that question over the next couple days? A lot, because I need you to remember it, right? So I'm going to ask you one more time. How do you find the inverse function? We have two parts of our lesson today. You saw that, right? The first part is inverse function. The second part is what? Composition of functions. Composition of functions is usually called Fogg and Goff. When you take pre-cal next year, you'll have to be able to do Fogg and Goff. When you take college algebra next year, you'll have to do Fogg and Goff. Okay? Whichever path you go, you're going to have to be able to do composition of functions in your next math class. So how about if we learn it really good now? Okay? Well, can you see why it's called Fogg and Goff? Because it looks like it says F-O-G and G-O-F. That's not what it's really saying. It's saying I want to do the composition of the function f and the function g. And this is the other way. I want to do the composition of the g with f. Okay? Another way this can be written is f of g of x. Or g of f of x. Does that make sense? So first things first, I have to tell you some stuff. Like how about if I tell you f of x equals x plus 5? And how about if I tell you that g of x equals 2x minus 6? Okay? Guys, what would happen if I ask you for f of 2? What would you do? Anywhere there was an x, I would put a 2, right? So 2 plus 5, that would actually equal 7, right? But look what I'm actually asking for. I'm asking for f of g of x. So that means anywhere there's an x, what am I going to write instead? G of x. So I'm going to start writing f, because that's the one on the outside. That's the one I start with. And instead of writing an x, I'm going to write a g of x. So g of x plus 5, right? Except what do we know? Yeah, I know g of x. G of x is 2x minus 6. So from here I can say 2x minus 6 plus 5. Except I know negative 6 plus 5 is what? So I have 2x minus 1. So f of g of x is 2x minus 1. Yeah? Can I also do g of f of x here? Yeah. I start with g this time though, right? So I start writing g, but instead of writing x, what am I going to write instead? F of x. Now, some of you I can see have already figured this out. Okay? This is the very beginning, so I always show you all the steps in the very beginning, don't I? Okay? We'll talk about what you're trying to say in just a second, if that's okay. I know f of x, don't I? So 2 times x plus 5 minus 6.
Pardon this interruption. At this time, I need the sophomore boys to report to the game gym. Sophomore boys sitting on the home side. Every other row over to the seat. Thank you.
2x plus 10 minus 6. Yes? And we can simplify that, can't we? To be what? 2x plus 4? They just didn't turn it off. It's okay. So, do you have any questions on composition of functions? Do you know which one to start with? Do you know which one to substitute into the one you're starting with? Well, guys, there's a really cool application of composition of functions that I would like to show you. Okay? So, draw a line so we know it's a new problem. Okay? I want to tell you f of x is 2x minus 4. Sorry about that. Let me scoot it up. And I want you to know that g of x is 1/2 x plus 2. I'm telling you those up front. You always got to know stuff to start with, don't you here? Okay? So first let's find f of g of x. Okay? What do I start with? I start with f, and anywhere there's an x, what do I write instead? G of x. Now here's what some of you already tried to do. Well, you tell me, what did you try to do a minute ago? Instead of physically writing g of x, what did you write instead? 1/2 x plus 2. I am totally okay if you skip that step, but do you see why I wrote it for you in the beginning? Okay, good. And then I have minus 4, right? Because that's the rest of f. That's the first page. So what do I do with this? Okay, distribute. 2 times 1/2 x. That's just 1x, right? Or x. 2 times 2. Ooh, nice. Well, let's do g of f of x now. So start with g. And instead of writing x, what am I going to write? F of x, exactly. And I know that f of x is 2x minus 4. And now, yes, distribute. So 1/2 times 2x. X minus 2 plus 2. Okay, so this is interesting, right? This time when I did f of g of x and g of f of x, what did I get? Yeah, not only the same thing, but exactly x. Okay? Do you recognize this? These two problems? Look at your first page of notes. Isn't this one of our example problems that we did that I said find the inverse? And what did we get? We got this one, right? When I do f of g of x and get x, and when I do g of f of x and get x, I have just proven or verified that these two functions are inverses. Does that make sense? What if I did f of g of x and I got x? Can I just stop and say they're inverses? No, you have to do it both ways, right? To verify, you have to do it both ways, correct? Okay? Again, it's not even just enough that we got the same thing. Like if I got 5x here and 5x here, that doesn't prove they're inverses. That just proves that they're both 5x. Okay? In order to be inverses, they have to get x. Why? Why is that true? What did I do? Let me see that real fast. What did I do to get an inverse function? I switched x and y. So this is really x. To get x, what does this really represent? Function notation, that's really y, isn't it? Function notation, that's really y. So I've said y equals x and y equals x. I've proven that they're inverse functions by doing composition of functions. Does that make sense? Okay. On your worksheets for homework, here's the ones I want you to circle. Okay? On inverse functions, please circle number 1 and 3 and 8 and 12 and 15 and 22. Notice for 22, you're verifying that they're inverse functions. Okay? And then also please circle number 26. On the worksheet called Operations and Compositions of Functions, notice that we did operations before we left for break. So I'm giving you a couple questions on this worksheet as a review, and then I'm giving you some composition of function problems. Okay? 1, 2, 3, and 4, 21 and 23, 31, and 37. So tell me about all the rest of the problems then. So we're starting off the semester by offering extra credit. Whether you choose to do it's up to you, right? You know I never look down on you if you don't do it. But if I offer it to you and you don't do it, probably not going to offer it again. Does that make sense? Any questions on this?